Alrighty, today I want to go ahead and discuss 1-2, definitions, postulates, conjectures, and theorems. I don't expect you to understand all of this in one day. I know this stuff is going to be pretty confusing, but I just want you to be aware that these things exist as we progress through the course. So let's go ahead and take a look at all these objects that we have here. A definition is the meaning given to a term. It is the formal statement that describes what the term is. So if we scroll down, or if we look at number 2 over here, this is an example of a definition. Geometry is that part of mathematics that addresses questions related to size, shape, measure, location, and properties of figures in space. So it's just basically giving meaning to the word geometry. Hence, this is definition, okay? A conjecture, by the way, is a statement that may be true but has never been proven. It is a guess based on known information, but it has neither been verified nor shown to be false. And this is basically, if you recognize a pattern, you're going to make a guess, okay? And it's okay if your guess is incorrect, you are still performing a conjecture. An example of this is this, number 4. Katrina walks into second period 2 minutes late on Monday. She is 2 minutes late on Tuesday and Wednesday as well. Her teacher assumes she will be 2 minutes late on Thursday. That is a pattern, and she is going to make that assumption, the teacher is. That is a conjecture right there. So we're going to go ahead and put conjecture. Okay? I'm going to go ahead and skip postulate because this is the most confusing one out of all of them. But let's go ahead and move on to a theorem. A theorem is a statement that has been proven to be true by accepted argument. It may be deduced from, for example, definitions, postulates, and other theorems. So what I want you to get from a theorem is that if anything you see in this class, if it's in the form if and then we're going to assume it's a theorem. Or if something, if you see an equation, for instance, if 2 plus 2, then 4, which can be written as 2 plus 2 is equal to 4. So, sorry, I should have written this first, but what I want you to understand is that this is the if part, and then that equals 4 is that then 4, okay? So, if then, okay, so let's go ahead and take a look at number 3. This is going to be a theorem because it is going to be in the form if and then if I write it like this. So the angles of a triangle always sum to 180 degrees. This is what a triangle looks like. It has 3 angles, so I'm going to say measure angle 1 plus measure angle 2 plus measure angle 3 is equal to 180. So the stuff before the equal sign is my if, and the stuff right after the equal sign is going to be my then. Okay, so this is going to be a theorem. Now, let's go ahead and take a look at undefined term. An undefined term is a term that is not given a formal definition. In geometry, 3 undefined terms are points, lines, and planes. So a piece of a line that begins at one point and extends forever in one direction is a ray, right? And I know it doesn't say ray here, but we've already talked about what a ray is. It's one of the undefined terms in 1-1. So we're going to go ahead and say undefined terms because we just gave a meaning to the word ray. So undefined term, okay? And then over here, number 1, we're left with this last one. That's going to be postulate. Now, a postulate is a statement that is accepted as true without proof. It is used to prove other statements, often as part of a theory. So if you're given a statement, we're just going to accept it as it's true, okay? And these over here, if I scroll down, are examples of postulates. So through any 2 points, there is exactly one line. Through any 3 non-collinear points, there is exactly one plane. A line contains at least 2 points. A plane contains at least 3 non-collinear points. Or if 2 points lie in a plane, then the entire line containing those points lie in that plane. Basically, postulates involving points, lines, and planes. If you have an undefined term that does something funky, and it creates something, we're just going to assume it's a postulate. Okay, so right here, the shortest distance between 2 points is a line. You got these 2 points. What the heck? They just created a line. That we're just going to accept it as is true. So that's a postulate. Okay, So that is basically this portion of our notes. Now I want to go ahead and take a look at this. It says, write a conjecture that describes the pattern in the sequence, then use your conjecture to find the next item in the sequence. So again, what a conjecture is if you recognize a pattern, you're going to form a guess. And it's okay if your guess is incorrect, but I can guarantee you that whatever your guess is, it has to be correct for this one. There should be a correct guess, so make sure that you follow along. Monday, Wednesday, Friday. Well, what's going on here? You're going to tell me what is going on. That's what the conjecture is. Write a conjecture that describes the pattern in the sequence. So we have Monday, Wednesday, Friday, and that, by the looks of it, that's just skipping a day. You skip a day. So then using your conjecture here, what is the next item in the sequence? So Monday, Tuesday, then Wednesday, Thursday, then Friday. After that, Saturday. So you're supposed to put Sunday. Okay, that was pretty easy. All right, B, 3, 6, 9, 12, 15. My conjecture, it looks like every time I am moving up, I'm adding by 3. So you're going to add 3. So using that conjecture, the add 3, so 15 plus 3, that's 18. So 18 should be the next term. All right, these arrows, I know that's going to be a little confusing, but I am rotating the arrow by 45 degrees clockwise. So arrow rotates 45 degrees clockwise. So it should look like this. Okay. D, I got 0.4, 0.04, blah, 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 blah. I am noticing that I am moving the decimal to the left. Like so. So move decimal to the left once each time. So then that should be 0.00004. Okay. Or you can say divide by 10. So you take that number, divide by 10, and then write it for the next one. Okay. Write whatever you got, whatever you produce, you're supposed to write it for the next term. So divide by 10. Okay. All right, for the following, determine if they are always, sometimes, or never true. 2 points determine a line. That is always true. To name a line, you need to have 2 points, right? So this is always. All right, if I have these 2 points here, you need to use those 2 points to name that line. 2 lines intersect in 2 points. So if I draw these 2 lines, well, do they intersect twice? Absolutely not. So that will never be the case. Never, never, never. Congruent segments have different measures. Okay, the word congruent, that means that they have the same size or the same shape. So if I were to draw a segment here, call that XY. I'm going to call that, I don't know, RT. And this is congruent to this. Let's say they're 3 centimeters, right? The segments are 3 centimeters each. Then they have different measures. Well, if they have different measures, they cannot be congruent whatsoever, right? So that should be never. Congruent figures should be same size, same shape. Alrighty, the next thing I want to go ahead and take a look at is coplanar points are on the same line. I'm going to say sometimes for this one because it's not always true. Because let's take a look at our postulates right now. Here's my plane. And there's a line right here. You can actually introduce a third point right here, and we'll call that, I don't know, R. And look at that. These points are coplanar because they lie on the same plane, but at the same time, these points, or these coplanar points, are on the same line as well, right? So that's shows an example of this is true. However, again, this is not always true because you can have coplanar points on the plane. You can have the points on the plane. However, you don't have a line. And this example over here shows that. So this is just sometimes. All right. Thank you so much. I'll see you next time.